Okay, so we were learning the derivatives of the composite function. So the composite functions means, in the last video we learned what is meant by the composite function. So the composite function is the function which is something that it is a function of another function. Okay, now in this particular case we can see that there is x raised to tan inverse of x. Then how to solve such type of the problem? Basically there is a exponentiation of something, x raised to the function of something. Okay, so how many composite functions are there? First of all, the tan inverse of x is itself the composite function. There is a one composite function, and this is a x raised to something, this is the second composite function. Okay, so these are the two composite functions, these are the two functions present in this particular expression. Now if I equate this to the y, so y is equal to x raised to tan inverse of x. Then in order to keep this tan inverse of x into the multiplication of this x, I have to apply the derivative, I have to apply the log. So whenever I apply the log on the both the side, so it becomes log of y, and this particular expression will become log of x raised to tan inverse of x. So whenever we apply the log on x raised to something, then raised to term will come into the multiplication. So I will get the log of y is equal to tan inverse of x multiplied by log of x. Now I have the two functions. Okay, so this is the function 1, this is the function 1, and it is the function 2, and both the functions are in multiplication with each other. So we know how to take the derivative of that particular two functions if they are in multiplication. So whenever I apply the differentiation on the both the side, so with respect to x, so it will become log of y, its derivative will become 1 upon y and dy by dx. So if I apply the derivative on this particular side, so it will become d by dx of tan inverse of x into log of x. So now how to solve this particular? So this will be as it is, so 1 upon y so this will be as it is, 1 upon y into dy by dx, and this will become the first function. Okay, so if it is a function 1 and it is a function 2, so first function as it is, derivative of the two functions and which are in multiplication. So the first function we will keep as it is, so tan inverse of x into derivative of the second. The second function is what? Log of x, its derivative. The first function as it is, derivative of the second, plus second function as it is, means log of x we have to keep as it is, into derivative of the first function. First function is tan inverse of x, so it is becoming the d dx of tan inverse of x. So it is a tan inverse of x into derivative of the log of x with respect to x is 1 upon x plus log of x. Now here I have to find out the derivative of tan inverse of x. So there is a standard formula to calculate this particular derivative, and that standard formula is 1 upon 1 plus x square. It is the derivative of the tan inverse of the x. Okay. Now just I have to simplify this. So tan inverse of x divided by x plus log of x divided by 1 plus x square, this is equal to 1 upon y into dy by dx, but I have to calculate the derivative of the y with respect to x. Now for that I have to keep this y in this particular multiplication. So dy by dx is equal to y into tan inverse of x divided by x plus log of x divided by 1 plus x square. Now I can keep the value of the y here, So the final output will be so dy by dx is equal to y means what? Y means x raised to tan inverse of x. Okay. So x raised to tan inverse of x multiplied by tan inverse of x divided by x plus log of x divided by 1 plus x square. So this is what the final output for this particular expression. Okay. Okay. Now in this particular expression, the derivative, we have to find out the derivative for this particular expression. Okay. So the first thing is that we have to think for the for some time, because it is a raised to x. So especially a, small a stands for the constant. So constant raised to constant is constant, and its derivative is 0. Okay. The derivative of this function of this particular term will be equal to the 0. A raised to x, okay, some constant raised to some variable, its derivative is the simple, there is a straightforward formula. So a raised to x into log of x. Now x raised to a, x raised to some constants, its derivative is power comes in multiplication, and then the power will be reduced by 1. But the important thing is that we have to concentrate on this particular x raised to x, since it is a composite function. So we have to take the derivative of this particular term. The important task in this particular example is to calculate the derivative of the x raised to x. So for that we will have to do this particular. So we will take this particular term outside of this particular expression. We will take the derivative of this term separately and then add all these particular derivatives. Okay. So let us suppose that so if I take this particular term outside of this particular expression, so let's suppose that so y is equal to, or say u, let's suppose that u is equal to x raised to x. Then there is a some term which is in exponential form. So last time we have learned, whenever we apply the log on the both the sides, so they will get cancelled on. So it will become the log of u is equal to log of x raised to x. So it will become log of u is equal to x into log of x. Now it's simple. So how to take the derivative of this particular? So for that I have to apply the derivative on the both the sides. So 1 upon u into du by dx. So whenever we apply the derivative on the both the side with respect to x, so it will become 1 upon u du by dx. Now this will become the first function. This is our first function, function 1, and this is our second function, function 2. So the first function as it is, derivative of the second function, plus second function as it is, and the derivative of the first function with respect to x, which is equal to 1. So it is x into derivative of the log of x with respect to x is 1 upon x, plus log of x, and derivative of x with respect to x is 1. So this x and x will get cancelled, so it will become 1 plus log of x. So finally we will get the du by dx. So it is the value of 1 upon u into du by dx. So I want only the du by dx, so which is equal to u into 1 plus log of x. But what is u? So u in this particular expression is x raised to x. So du by dx is equal to x raised to x into 1 plus log of x. So u means what? Derivative of x raised to x is equal to x raised to x 1 plus log of x. Okay. Now I know the derivative of this x raised to x term also, okay, which is equal to what? X raised to x into 1 plus log of x. Okay, now how to take let's suppose that I will keep so for this, whenever I put, suppose let's solve this particular, so let y is equal to x raised to x plus a raised to x raised to a plus a raised to x plus a raised to a. Now how to solve this particular problem? So I know the derivative of the each and every term. So if I calculate this particular, so dy by dx, so dy by dx is equal to derivative of this expression with respect to the x. Now it is equal to derivative of this expression, we know, we have calculated earlier, x raised to x into 1 plus log of x. Derivative of this term is power comes in multiplication, power will be reduced by 1. Derivative of this term, a raised to x into log of x, and the derivative of a raised to a, which is a constant one, so its derivative will be the 0. So finally I will get the output as dy by dx is equal to x raised to x 1 plus log of x plus a into x raised to a minus 1 plus a raised to x into log of x. So this will be our final output. Okay, so the simple trick in this particular formula, in this particular type of the expression, is that whenever there is a composite function, so take that particular term outside, such that here in this expression the x raised to x is the composite function, so we have taken that particular composite function outside. Okay, let us suppose one of the variables, say u is equal to x raised to x, then apply the log, then apply the derivative and find out the final derivative of that particular term. So this derivative of x raised to x we have calculated separately, and then we have applied we have assumed this expression to be equal to the y, and the derivative of y is equal to the sum of the individual term derivative. So we have taken that particular. So like that, like this we have to solve such type of the problems.